Cloud architects face a persistent challenge when deploying generative AI. They need the vast intelligence of non-deterministic foundation models, but they must force those models to execute tasks predictably without incurring massive compute costs. We solve this by moving up the model customization ladder. This framework outlines 4 distinct steps to align a model with business goals: prompt engineering, retrieval-augmented generation, fine-tuning, and pre-training. Look at the base of the ladder. Prompt engineering is the mandatory first step. It requires 0 changes to the underlying cloud infrastructure, making it the fastest and lowest cost option to deploy into production. Compare this to the higher rungs. Retrieving model weights or pre-training a new model from scratch demands extensive labeled datasets, specialized machine learning teams, and hundreds of hours of heavy GPU compute. Before an enterprise provisions a single training cluster or modifies a database, they must completely exhaust the capabilities of prompt engineering. The mechanism that makes prompt engineering so efficient is called in-context learning. We package specific instructions, formatting rules, and historical examples directly inside the prompt payload. This entire package is sent to the model and processed at runtime, while the model's internal neural weights remain entirely frozen. We are shaping the final output solely during the inference phase. We are not permanently adjusting the mathematical parameters of the foundation model itself. This means an organization can take a single, unmodified foundation model and dynamically pivot it to perform hundreds of distinct tasks securely and cost-effectively, relying entirely on the text inputs we provide. A hobbyist typing "summarize AWS" into a chat window is using a naive prompt. Single-sentence queries lack constraints, leaving massive room for the model to speculate. That speculation inevitably leads to unpredictable outputs and hallucinations. Enterprise-grade execution requires an enhanced prompt, a strict architectural framework that leaves nothing to chance. This framework consists of 4 main constructs. The instruction defines the core task. The context establishes boundary rules and assumed roles. The input data is the raw text to process. Finally, the output indicator sets strict formatting constraints, forcing a specific structure like JSON. By treating a prompt as a rigid, structured architectural payload rather than a conversation, we eliminate model speculation. The system is forced to return predictable, machine-parsable outputs every single time. Depending on the complexity of the task, we apply different prompting techniques. The baseline is 0-shot prompting. Here, we present a task without providing any examples, relying entirely on the model's pre-trained knowledge to generate a response. When we need specific formatting or logic, like strictly categorizing support tickets, we upgrade to single-shot or few-shot prompting. By including 1 or more high-quality input completion examples within the prompt, we establish a definitive pattern for the model to follow. For complex logical or mathematical problems, we use chain-of-thought prompting. By simply adding an instruction like think step by step, we force the model to articulate its reasoning before delivering the final answer, which drastically reduces calculation errors. Knowing what not to say is equally critical. Negative prompting involves explicitly defining the topics, terminology, or behaviors the model must actively avoid. If a company needs its customer-facing chatbot to adhere to a specific brand voice, negative prompting allows us to ban overly complex technical jargon or casual slang from the outputs. Iteratively layering these precise techniques, few-shot examples alongside strict negative boundaries, achieves exact tone alignment. You get the targeted customization of a highly specialized model at a fraction of the cost of fine-tuning. Beyond the text payload, architects control the model's generation mechanics at the API level using inference parameters. These are the runtime dials that govern randomness and vocabulary boundaries. The most common dial is temperature, which scales word probability. A low temperature, like 0.2, forces deterministic, highly predictable outputs, ideal for generating code. A high temperature, closer to 1.0, flattens those probabilities, resulting in creative, diverse, and unpredictable text. To restrict the actual pool of words the model can choose from, we use top K and top P. Top K limits the model to a fixed, hard-coded count of the most probable tokens, say only the top 10 options. Top P, or nucleus sampling, is dynamic. It considers the smallest set of words whose cumulative probability adds up to a specific threshold, like 88%. To prevent runaway generation, we enforce strict boundaries using maximum length limits, and we define stop sequences, specific character strings that immediately halt the model's output, maintaining clean chat formats. When optimizing these API calls, developers often worry about speed. The true drivers of prompt latency are the size of the underlying model, the specific architecture type, and the total volume of input and output tokens being processed. Here is a critical distinction for your architecture designs. Adjusting the temperature, top P, or top K parameters has absolutely zero impact on inference speed. Architects have complete freedom to tune a model's creativity and vocabulary spread. You can dial these sampling parameters up or down to dial in the perfect response, without ever violating your application's latency targets. Because prompt engineering relies on natural language to dictate system behavior, it introduces a unique class of security vulnerabilities that traditional software defenses are not equipped to handle. The first two major threats are prompt injection, where a user embeds commands to override the baseline system instructions, and prompt poisoning, the intentional corruption of the data or instructions fed into the model. Then there is jailbreaking. This occurs when an adversarial actor uses complex, structured prompts to deliberately bypass the model's built-in ethical and safety constraints. A highly effective version of this is many-shot jailbreaking. By providing an overwhelming list of malicious input-output examples in the prompt, an attacker can override the model's safety conditioning and force it to produce restricted content. The fourth threat is prompt leaking, where an attacker successfully coaxes the system into revealing its proprietary internal system instructions or exposing sensitive data. Foundation models process all text as a single stream. They cannot inherently distinguish between secure developer instructions and malicious user inputs. Therefore, the surrounding cloud architecture itself must provide the defense. Securing generative AI workloads requires a multi-layered defense architecture deployed across the AWS environment. The first line of defense is utilizing strict prompt templates to establish unyielding boundary rules, combined with active input sanitization that filters out adversarial commands before the payload ever reaches the model endpoint. Next, organizations deploy guardrails for Amazon Bedrock. This service sits between the user and the model, automatically blocking harmful content, filtering toxic language, and redacting personally identifiable information from both inputs and outputs. The final security layer is access control. By configuring AWS identity and access management with strict least privilege policies, we ensure that users and applications can only invoke the specific models they are explicitly authorized to use. To practice building these structures safely, AWS provides PartyRock, a free, no-code environment powered by Amazon Bedrock, where you can experiment with prompt templates and manipulate inference parameters without risk. Mastering prompt engineering requires both the finesse to architect precise language payloads and the technical discipline to secure them. That combination transforms raw artificial intelligence into a reliable, enterprise-grade solution.